so the negative exponent rule is challenging. It's weird. But you can do it. Okay, you're just going to have to really focus. So, I want you to think about if the negative exponent rule example that I want you to first see is not on your paper. Okay, I'm just going to come up with one. So, say we have 4 to the 6th power. And that's going to be 4 times 4 times 4 times 4 times 4 times 4, 6 times. And 4 to the 10th power. No, that's going to be confusing. 4 to the 8th power. 4 times 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 4. Okay, so we've got 4 to the 6th divided by 4 to the 8th. Now, if we were to solve it with the with the quotient rule that we just learned, what does your quotient rule say to do to 4 to the 6th over 4 to the negative 8th? Subtract the exponent. So it's going to become 4 to the 6 minus 8, which is 4 to the negative 2nd power. Okay? Now, if we were to solve it this way, by just crossing them out, which is still the quotient rule, if I cross all of these out because they divide perfectly, then I'm going to be left with 1 over 4 to the 2nd power. Now, did I start with the same value? Did I start with the same problem? 4 to the 6th power over 4 to the 8th. Did I start with the same thing? Did I end up with, what does your brain tell you that you should end up with? Should you end up with the same answer? Is that what your brain says? If you start with the same problem, you should end up with the same answer, right? For both problems. Okay, if I have 4 plus 9, should I end up with 13? If I start with 4 plus 9, should I end up with 13? Okay, so your brain says that you need to start with the same problem and with the same answer, right? But what do your eyes say? Do your eyes say that you ended with the same answer? No. 1 is 4 to the negative 2nd power. 1 is 1 over 4 to the positive 2nd power. So your brain tells you you should end up with the same answer. Your eyes tell you you didn't end up with the same answer. So I'm going to teach you how to fix that problem. Okay? Because these indeed are actually the exact same number. 4 to the negative 2nd power is the same thing as 1 over 4 to the 2nd power. They're the exact same value. Okay? So, that's where this comes into play. This is what's called the negative exponent rule. Okay? What this states is that the value or the term or the thing, if you want to, that's attached to a negative exponent is going to get flipped. Okay? So, in this case, I want you to look at this first example. What is attached to the negative exponent in this problem? A? 5a. 5a, oops, need a color here. 5a is being raised to the negative 2 power. So what's attached to the negative power? 5a. So what's going to get flipped? 5a. So this was over 1, so it's going to get flipped into the denominator. Okay? So it's going to become 5a. 5a is what was attached to the negative exponent. 5a is what's going to get flipped into the other place. Okay? Just stay with me. It's going to get easier, I promise. Okay? Then, the second step, so we've already flipped it. Second step is to change the exponent from a negative to a positive. Okay, we changed it from a negative exponent to a positive exponent. You see that? Okay? So now, we take 5a times 5a. Well, the 5's can be multiplied, so that's what's happening here. 5 times 5 is 25. a times a is a squared, a to the second power. Is there anything else that can be changed? No. So is it as simplified as it can go? Yes. Okay. So let's do the second example. Okay, this is hard. It's going to continue being hard. You're just going to have to keep practicing. And once you start practicing, it's going to make more sense. I promise. Okay? This is not as easy as the product rule or the power of a power. I know that. Okay, this one's weird. So, we have a negative exponent, yes? What is the negative exponent attached to? 2x. That's what it's being attached to. So what's going to get flipped? 2x. Okay, so it's going to get flipped into the denominator. Nothing is left in the numerator, but we still need to keep that 1 there. There's nothing there except for a 1. We don't want to have a 0 there because 0 is not there. It's just the value of 1. So 1 over 2x, that got flipped. What happens now to the exponent? It turns positive. Very good, Abby. It turns positive. So, once we flipped it, then it becomes positive. Okay? Now, this is going to be 1 over now 2 to the x to the first power. Do I need that first power there? No. Not necessarily. So you can leave it as 1 over 2x or 1 over 2x to the first power. All right, number 3, or the third example in the table is a little different. It starts out in the denominator now. Okay? The negative exponent does. Now, what is the negative exponent attached to in this case? Just the x. Okay, it's not attached to anything else. So is the 1 going to stay where it is? Yes. Okay, so now it's going to become 1 times x. And what happens to that exponent that was attached? It gets flipped up 2, and it becomes positive over 1. Now, 1 times anything is what? Itself, the anything, right? So this is just the same thing as x squared over 1, or just what? X squared over 1 is just what? X squared. Very good. Let's write the rule. What did we say is happening in these problems? Okay, so the negative exponent will become positive once what has been flipped? The base. Okay, so whatever it's attached to, right, whatever the negative exponent is attached to, becomes positive after the base has been flipped like a pancake. Okay, so let's put that into simpler, easier, less words. Okay, so let's say whatever the negative exponent is attached to will get flipped. Whatever the negative exponent is attached to will get flipped. Okay? It will get flipped, and that also, I'm going to put a little star, negative exponent becomes what? Becomes positive. I'm just going to put a plus sign for positive. Is that okay? Okay. The first thing that happens is flipping the base either into the denominator if it's in the numerator, into the numerator if it's in the denominator, which we saw both examples of, and then that makes the negative exponent become positive. So in this case, let number 2, a to the negative m is going to become what? it's going to be a to the positive m, but where? On the bottom. It's going to be in the numerator. So it's going to be 1 over a to the positive m. Perfect. 1 over a to the positive m. Okay, so 8 to the negative third power. What is attached to the negative exponent? 8. 8 is attached to the negative exponent. So what is going to get flipped? 8. 8 is going to get flipped into the denominator. What's going to happen to the exponent? It becomes positive 3, and then we're still left with the 1 on top. 1 over 8 to the third power. Okay? Now, did we change the value of 8 to the negative third power? The value. No, we did not change the value of 8 to the negative third power. Did we change the way it looked? Definitely yes. All right, letter B. Letter B, what is attached to the negative exponent? Z. What about the 5? No, nothing is changing to the 5. So am I going to keep the 5 the same? In the same place? Yes, nothing is going to happen to it. So it's going to stay in the numerator. What's going to happen to the Z? Where is it going to end up? In the numerator or the denominator? It gets split. Where does it go? To the numerator. So it's going to become Z to the third power. Is there anything in the denominator? 1. Yeah. Do I need to include that? If you want to. If you don't want to, you don't have to. Is the 1 in the denominator changing the value? No. Okay. Now, I want you to do C by yourself. Oh. Oh, look at that. All right, so what is attached to the to the negative exponent? 5a, not just the 5, not just the a, but the whole piece, 5a. Okay, so that's going to become, what's going to happen to it? Whatever is attached to the negative exponent does what? It gets flipped. It gets flipped like a pancake. So it's going to go in the denominator, 5a raised to the second power. The whole thing. Yes, I want you to put parentheses. Hold on. So here's what I want you to consider. If you do not put parentheses, what is being, look up here please. What is being raised to the second power if we don't include parentheses? Only the a. What is being raised to the second power in this case? All of it, 5a. Do you see that these two things are not equal? They are not equal at all. So you have to include the parentheses. If you want to expand it and write 1 over 25a squared, you can. If you leave it like this, I would accept this also. Okay?